Yes, you are welcome to class today. And in today's class, we are going to be talking about transforming a relationship to a linear form. Transforming a relationship to a linear form. This is episode 5 under logarithms. In our last episode, we checked how to solve exponential equations, and I gave you some questions to practice. Let's check the answers to those questions. Here are the questions I gave in the last episode on solving exponential equations. If you have not seen the video, please check it out and try to pause the video and solve this question. Yes, we just have 13 questions here. They are not much. Pause the video and solve the question. But if you have done the needful, you've solved the questions, here are the answers to them. Okay, this is exercise 2E. Yes, here are the solutions. Please feel free to pause the video at any time to check whether you are right or wrong. Yes, here are the solutions to those questions. Please take your time to go through them and feel free to check your corrections to resolve and reattempt any of them. Okay, thank you very much for solving that, and that will be the answer to that question in the last episode. So let's go back to our work today. Today we want to transforming relationship. When you are given any logarithmic expressions, we want to transform them to a linear form. And at the end of today's class, the objective should be students should be able to use logarithms to transform a given relationship to linear form and hence determine unknown constants by considering the gradients and or intercepts. Let me show you the question we should be able to do at the end of today's class. Yes, at the end of today's class, you should be able to answer exercise 2H. Yes, here are the questions under this topic. I would like you to pause the video and try out the question. Yes, try them out. Pause the video and try out the questions. Okay, we are going to look at how to apply logarithms to solve questions like this. I will pick some questions from here to solve. Then I will expect you guys to also do the needful by practicing yourself. You know, practice itself make perfect. Let me start with question 1. I'll just pick question 1 to explain. Then maybe I'll do question 2. 2 and 3 are similar, so that with that you have an hint on how to go about it. Okay, yes, I move them to the board and I have the question here. I will just solve maybe 1 or 2. I solve question 1 in question 1 and I will probably solve question number 2 so that you can do all the questions you have in the exercise. Okay, which one should I do? I do 1B, then you do the rest. For 1B, let's first read out the question. The question says, okay, let's read out the question. Given that A and B are constants, use logarithm to change each of these to non-linear equation into a y is equal to mx plus c. State whether the variable x and y and the constant m and c represents. Okay, we can have different methods to solve this. Okay, let's see how to do that. So for the first question that I want to do B. I'm given that y is equal to 10ax minus b. What am I going to do to this question to write it in linear form? I will take log of both sides. Log of both sides. I can take ln of both sides. This is log to base e. Whenever you see ln, it's log to base e. So let me take log to base e of both sides. Okay, ln y is equal to ln 10 ax minus b. Okay, if that is the case, then this guy can go backward and I have ln y equals to ax minus b. Ln y equals to ax minus b. And I can say let my ln y be capital letter Y. If ln y is capital letter Y, then I have ax minus b. Here, my capital letter Y is ln y, and this is my intercept. It still remain big X, and my gradient is m, and my constant is minus b. So I can write it out that my big Y is ln y, and my gradient is a, my x still remain x, and my constant, that is intercept, is minus b. And that is what you are asked to do. I've linearized this by writing ln y, by writing y ax minus b. You have linearized it. Very simple and straightforward. Just take ln of both sides. Let me do one more. Somebody say I should do question h. For me to do h, I'll just put ln, take ln of both sides. Then I will have ln y is equal to ln a e exponential bx. Mind you, this one is the same thing as ln y equals to ln a, or I put a outside, and I have minus b coming to the back. This is plus minus bx. So I can do, this one is like, you have ln a times ln exponential this. So it will be plus. So I can roll this one down. I have ln a minus bx. So from here, I can move on to show that ln y is equal to ln a minus bx, where I can change this guy to my capital letter Y and change x still remain x. This will be my c, which is constant c, and this will be my gradient m, and my x still remain my x. So this thing can be written as y equals to minus bx plus ln a. So where y is ln y, and my gradient is minus b, my x still remain x, and my c is ln a. That's it. That's how to do that. Simple and straightforward. Okay, let's check one more question, which is question 2. Okay, here is the question 2. Let's see how to solve this question. Let's just read out the question. It said the variable x and y satisfy this equation. Y is equal to ax and a times x raised to power n, where a and n are constant. The graph ln this and ln x is a straight line passing through these points. As shown in the diagram, find the value for a and value for n correct to two significant figures. What you need to do is just try to find this expression, try to transform it to linear one. There are a lot of methods to use, but let me just use this one. Let me take the natural log of both sides. So I will have ln y is equal to ln a plus n ln x. So from this transformation, this will now be my capital letter Y, this will be my c constant, this will be my gradient, and this will be my x. Okay, for me to get this, find a and c, I can just try to know the value at each of these points. Let me make this one to be my C, okay, and work with it, and this N to be my M. Let me just work with it from this graph. From this place, I know that my Y, let me deal with the point 1 first. Point 1, this X and Y, meaning that 4.02 equals to, let me put it here and see what I will get, equals to, my C still remains C for that graph, N, and my X, it will be times 0.31. Call this one equation 1. I can write this as C plus N, okay? C plus is 0.31, N equals to 4.02, equation 1. So let me do it for the second one. For this point, I will have, for that point, I will have 3.22 equals to, my C remains C, and I will have 1.83 N. So I can rewrite this as C plus 1.83 N equals to 3.22, equation 2. I can solve these two equations simultaneously to find C, and any answer that I get for C, I'll find the lane of it. Okay? So I want to find C and N. Let's solve simultaneously. If I'm to solve this equation simultaneously, I can use either elimination or substitution methods. But me, I will just use my calculator to do this straight up, and you too can use your calculator. Just show what you are doing. Solving this simultaneously, solving equation 1 and 2 simultaneously, then I have the coefficient equation 1. Coefficient of C in equation 1 is 1. Yes, coefficient of N is 0.31, and coefficient, the constant there is 4.02. For equation 2, we have 1 as coefficient of X, 1.83 as coefficient of N, and 3.12. So let's find my C now is 4.183 dot, and my N in this equation will be minus 0.5263. But the question asks us to put it in two significant figures. N is equal to minus 0.53 to 2SF significant figure. So my C is my C, which is 4.183 is equal to lane A. So let me take the natural log of both sides. So A will be equal to E183, which will be 66 approximately. So my A is 66, while my N is minus 0.53 to 2 significant figure. So that's the answer to that questions. Thank you very much for watching this episode. You can pause this video and try out question exercise 2H. And when you are ready to see the answer, please play the video. Okay? Let me reveal the answer now. Here are the answers to these questions. Yes, 2H, this number 1, B, E, the 2 we just solved. You can see that our A is 66. Okay, our A is 66. Can move on, and that is correct. That is number 3, number 4, number 5, number 6, number 7, and the last question 8 is here. Thank you very much for watching this episode. See you in our next class. Bye.